two things, vector versus scalar. Scalar it's actually a quantity that describes or described, maybe instead of described, how it describes only the, I'll go with this, only the magnitude. If you said I'm driving, my speed is 75 miles per hour. That is a scalar. If you say the wind outside is 25 miles per hour, that's a scalar. It's only giving me how strong the wind. It doesn't tell me which direction it's coming from or is going to. A vector, on the other hand, what's a vector? A vector is a quantity that describes the magnitude and direction. Maybe that here instead of that. That describes the magnitude and the direction. Now, for example, I can say my velocity, how fast I'm going, it's 75 miles per hour, and I'm heading, for example, east. I'm getting in my car, I'm going to drive east at a speed of 75 miles per hour. That is a vector. I'm giving you how fast I'm going, that's the magnitude. I'm also giving you the direction I'm going. The soccer field is 200 meters north of us. That's also a vector. The soccer field is 200 meters, so that's the value how far you have to go in which direction, north of us. The wind is gusting at 75 miles per hour. We have a tornado here. And I can give you the direction, the heading direction is heading at 40-degree angle. 40, when you measure them, you know that's at that direction, the 40-degree. It's like halfway between what? North and east, 40 degrees. North on the top, south on the bottom, east on the right, west. So this is almost northeast or east-north. You can look at it either way. At 40 degrees north of east. So we know which way, the wind. Now when you have a vector, we always write the vector. For example, wind, I might say W with the line over it. And that line to indicate that it's a vector. We've done tons of these in physics. Tons of them. We dealt with vectors all the time. Or we might say vector A. Sometimes you see me just throw one arrow instead of two arrows. Lazy. And the way I write the vector, if it was this one, I will go vector A equals 75 angle 40 degrees. That's how I write them. It has a magnitude, it has a direction. Vector F, the field, that's 200 heading north. North is what? Isn't that 90 degrees from the east if you look at the north? If you look at your when we look at the northeast, southwest, now we normally measure everything from this line. That's your reference. So this is north, this is south, this is east, this is west. So when we say it's 200 meters north, you're going upward. What degree is that? 90 degrees. The velocity here, 75 miles per hour east. We go, the velocity is what? 75 miles per hour, what angle? If you're going east. That's angle 0, because you go in that direction. You always measure the angle. Reference is this one, this line. So that's 75 angle 0. Now, how do we add vectors? We're going to add them actually graphically in this section. Add them and subtract them. That's why I gave you protractors. Then we'll do them using trig. Well, not nobody likes. 9 out of 10 times, if you find me, you ask me, do you have protractor? I'll say no to you. I don't have it. I don't carry this with me all the time. I brought it in for today's class. That's it. Once we're done with this, you're not going to see it. So how do we add vectors and subtract vectors graphically? So let's say I gave you two vectors. Vector A is equal, I don't know, here we go, 50 angle 30, and vector B, what do you want to make vector B? 40 angle 120. And the question, can you tell me what is A plus B? What's vector A plus vector B is equal to? And again, I'm going to do them graphically. I know where the 30 degrees in the first quadrant. I know where the 120 in the second quadrant. So when I put my axes down, I'm going to leave space on the top. I'm going to have more space on the top than the bottom, because that's where I'm going to be. So this is my x and y axes. Here we go, x axis, y axis. Let me start with vector A. 50 degrees, the value 50 at angle 30. Now I got to use a scale. What are you going to use? Because you're not going to use 50 centimeters here. You don't have enough paper. So what I might do here, I might say, you know what, for a scale, I'm going to say 5 units here equals 1 centimeter. That's the scale I'm going to use. 5 units is equal to 1 centimeter. So when I graph this vector, first is a 30-degree heading. I got to find out where that heading is. 30 degrees. There's my protractor. Where's the 30-degree heading? Is right here. Can you see yours? Can you see mine? That's a 30-degree heading. I'm going to be going in that direction. So find where your 30 degree is. Put a little notch there. And now I got to measure the length of it. Since the length of this vector is 50, my scale is what? For every 5 units, I'm going to use 1. So what's 50 divided by 5? 10 centimeters long. So I'm going to make this, I'm using centimeter, 10 inches too long. So that's 10 centimeters. That's vector A. And if you're careful enough, that's your vector A. Now after that, I need to add to it vector B. So to add vector B, I'm going to go from the tip of this, the end of this one, and draw another set of X and Y axes. From the tip of that, draw an X and Y axes. And let's find out where angle 120 degrees is. Where's 120? It looks like in this direction. Can you see the 120? That direction. This is 0 all the way 100, 90, 110, 100, 110, 120. And how long vector B should be? It's 40, but what's my scale? 5 units for 1 centimeter. So what's 40 divided by 5? 8? Bless you. That's vector B. And the result of that, the answer you're looking for, I'll make it red here so you get to see it. A plus B, I'll make it blue. A plus B is going to be this line. That's A plus B. You measure the length of it. What's the length? I got roughly 12 and a half. Is that what you got? See that? 12 and a half. So A plus B equals, my scale is what? 5 to 1? So 5 times 12.5, that will tell me what the value of that. And what's the angle? Well, let me measure that angle. Let me lay my protractor here. I know it's not 70. Could be either 67 or 68. I can't tell. So I'll go 68 degrees. So what's 5 times 12 and a half? It's actually 62 and a half, angle 68 degrees. That's A plus B. We can't tell you if that's right or not yet, till we do them mathematically. Then we'll see if the number agrees with us. Now, a lot of people don't do them this way graphically. They don't want to do another set of X and Y axes here. I'll show you another way of doing them. Let's redo the same problem differently. We'll end up with the same answer. Most of it, because if you do a graph, you're always going to be off with the graph. And I'm using 5 units for each 1 centimeter. Now again, since most of them are in the first and second quadrant, when you graph them, make sure you have more of the first and second quadrant. Notice my third and fourth really tiny. Let's measure the first one, which is the 30-degree angle. Notice I'm a little bit off there with my axes here. They're not really exactly .90 degrees. So the 30-degree angle is right here. And how long that vector? 50. So a scale will be what? 10 units? 10 centimeters? That's A. Now watch this. Instead of putting your X and Y axes right here, this method said just graph this vector, 40 angle 120. Where's the 120? $120 is somewhere here. And what's the length of that vector? 8. And to find the result now, what you want to do is do a parallelogram. What's a parallelogram? This side is parallel to that, this is parallel to this. So I take my ruler and I slide it upward. Hopefully I don't change it. Does that look like parallel to that? That's why I don't like this method. And I got to do one parallel to this. 10 centimeter long if I go up there. So we make a parallelogram. So this is just for the parallelogram. Again, I don't like this method because you got to move that ruler there and you're counting on your eyes to keep it the same distance. So your result will be the diagonal, whatever that diagonal value is. That's A plus B. So you measure the length of it, you measure the angle, and you have your answer. So A plus B is equal to, let's measure the length of that. and I got 12 and a half, or 12.4, you know. So 12.5 times my scale, which is 5. And the angle is going to be, where's my protractor? I got about 69 with this one. Again, I could be off by 1 or 2 degrees when I use this method, because I'm moving it up and down, try to eyeball it, make sure they're parallel. I really got 12.4 here instead of 12.5. It should be the same answer if I'm careful enough. So it's 62 and a half, angle 69 degrees. Some people will do it this way, others will do it the way I did it on the other one. Yes, Tom. You measure the angle of the blue line. So you take your protractor there, Tom, and you put it over, and you read that number. Notice a little bit less than 70. Might even be close to 70. 69 degrees, here we go. Again, probably none of us get the same answer. Probably your numbers might be a little bit off. It depends how careful you are or not. It depends if you're using a big pen or a small pen. If you're using a big pen like this one, the thickness of each one, it's more than 1 millimeter. So when you multiply it by 5, you're already off by what? Half. So it doesn't take much to get the wrong answer with doing Graphical, but at least it gives you an idea where the answer is. Your answer is going to be in the first quadrant when you add them, and that's the result. Now you might be saying, where do you use vectors? A quick example, I can give you that here. If you have a plane that's taken off from here and heading in that direction, and if there is no wind, that plane will go in that direction all the way to that spot. But if you get a strong wind blowing in that direction at 40 miles per hour, guess what's going to happen to that plane? That plane is going to drift. Instead of going that way, still going to be pointing in that direction, but that's what's going to happen to it. So you point in that direction, but it's drifting. And it's going that direction. Yes? I'm going to do it, yep. So you're pointing the plane in that direction, but the wind is pushing it. Just like if you're in a canoe going across the river there and the water's moving. You point in that way, and you think you're going straight, but you're really drifting the whole time you go in that direction.
So how good is autopilot?
Well, the autopilot is actually what you have to do is figure, I need to point the plane in that direction, and let the wind push me in that direction to land there. So before the pilot actually gets in that plane and fly it, you got to figure out the wind, call for the number, and make the adjustment.
Well, I heard sometimes when you're about to take off, they give you the height that you're going to be flying, the wing.
Well, all that stuff before I fly a single engine plane.
Yeah.
So before we go, we get the weather report. If I'm going from here to there, I know which way the wind's blowing. I can figure out which direction I need to go. And I don't use trig. We have some plastic device. You turn them. The wind is this way. I'm going that way. It tells me which direction I gotta go. Now with GPSs, once you're off by 1 degree, the machine corrects itself. It goes, oh, you go in that direction. It pulls you in that direction. Or you see yourself off track, and you can move the plane in that direction. Yeah. But the old fashioned of flying there, we didn't have all these. When I used to fly before, I didn't have a GPS. So I go location to location to location to location, because we have all these airports sending signals. I don't want to go too far and get lost. I go from this airport to that airport to this one to that to this to this to this to my location. I think 2 weeks ago, a commercial plane with about 200 people landed about 150 miles in a different airport. Yep, because the pilot didn't make adjustment for that wind there, and he thought he was going in this. Everyone said in his defense, the runways look the same. No, it shouldn't happen.
Well, someone's about to be fired.
It shouldn't happen. It really shouldn't. But what about if I want to subtract them? Let's say I have two vectors. Vector A is 100 angle 50, and vector B is 75 angle 45 degrees. And I'll do three of them. And vector C equals 90 angle 110. Let's make it more than 110. 150. I'm just thinking about the piece of paper. And I want to find vector A minus B plus C. As I said, I like the other method better because I don't have to slide my ruler and worry about making a mistake there. I can see all my numbers in the first and second quadrant. You know what? I'm going to try to be careful this time. I'll put the x-axis first. And to make sure I'm good, I'll mark where the 90 degree is. I'll put the 0 on this line and the 0 on that line. Oh, I moved it by mistake. And there's the 90 degree. So my y-axis is going to be, hopefully, I can keep it straight. $175.90. You know what? Let me just a different scale. Let me make the 75. Actually, make it 70 instead of 75. This one is a different scale. I don't think it's always a 5, because you might think, oh, the scale is always a 5. No, the scale could be any scale you want to use. So I'm going to make my scale 10 units, 10, not 5, equals 1. So this will be 10 long. This will be 7. That will be what? 9. So I can choose any scale I want to. The first vector is vector A, which is 100 angle 50. Let me find out where angle 50 is. Here's angle 50, right there. And how long this vector? 10 centimeters long, because I'm using scale 1 centimeter for 10. This is vector A. Now notice I'm going to put x and y axes right here. That's how the other way I did it. Especially when you have more than two, you want to do them this way. And vector B is what angle? 45? Where's my 45? .45 is in this direction. Very similar to 50. I wasn't thinking about it. You know what? Because I want you to see it. Let's change that 45 actually. Let's make it 35 because I want you to see what's happening there. Because the 45 and 35 are almost on top of each other. Where's my whiteout? Here we go. Let's make that vector 35 instead of 45. So where's the 35? In that direction. And how long this vector is going to be? 7. But wait a minute, you're subtracting this. So instead of drawing that vector going in that direction, guess what you want to do? You want to do it coming back because you're subtracting that. And it's going to be how long we said? 7. Because it's subtractions. If I left it at 35, they're almost on top of each other. That's why I changed it there. So let's make it 7 units long. That's right here. So this is vector negative b. If I was adding, I would go in that direction. But because I'm subtracting, I'll come back. Change it completely 180 degree. Now again, put another set of x and y axes right here. And now let's see, where is vector C? Vector C is what direction? 150, right? Let's find out where the 150 is. 150 is in this direction. And how long that vector? 9. I'm adding that, so I'm not going to change the direction. That's vector C. So what's my answer to these vectors? A plus B minus C. Here's my answer. You start from the origin all the way to the end of the last one. So this red vector is A minus B plus C. Yes, always from the origin to that one. Now, you measure the length of that vector. Remember your scale. I'm getting almost 11, right? Is that what you got? 11? And your scale is what, 10? So the result is going to be 10 times 11. What's 10 times 11? 110. And what's the angle? Measure from the origin now. The original one. Is it 32 or 33? Maybe 132? 133? Somewhere there. Again, my pen itself has a thickness of more than 1 millimeter. I'm using there. The length of it is what, Tom? Measure the length of the last vector.
11.5.
Okay, and your scale is what? 10 to 1. So you take your 11.5 times 10, you end up with 115. Notice I got 11, Tom got 11.5. Miles, what'd you get? When you measure the length?
I got 11.2.
11.2? 3, so he's 113. Fran, what'd you get? Tran, what'd you get for length when you measure? What is it, 11.8? Yeah, you got 109.8. Damien, what'd you get? 11. Adele is still working on it. Well, on the homework, if you're smart, you use the second method. If they're looking for the exact answer, this is not the way to do it. If you're looking for the exact answer, you want to do it the other way. What other way? Using trig. Now, and sometimes actually the book will have fun if they say, I want to find 2a minus b plus c. If they put a 2 in front of a, so what do you want to do? You want to make that vector a how long? Twice the length of it. It's the same direction, but twice the length of it. So if you see a number in front of that, if you see a 3, make vector a 3 times the length of this. So if you're using 10 centimeters for it and you said 3a, you'd use 30 centimeters. And so forth. As I said, it's not the best way of adding and subtracting vectors because you just get a neighborhood answer. I asked 5 people, I get 5 different answers. We all did the same thing. So if you want to get the exact answer, we need to look for different techniques, and that's the second method, which is section 9.2, by finding, well actually section, not yet, it's finding the components first. I'm sure section 9.3 will be, or maybe at the end of 9.2. Let me see. Yep, we're doing that components for now, then section 9.3, we'll add them using trig, using the components.